Greetings and welcome. Today we're turning our attention to a particular case and the implications we can draw from that case for the topic of industry safety and government regulation. This is the case of the Fukushima Daiishi nuclear accident of 2011. This was the largest nuclear disaster in the world since Chernobyl, and in one sense it was a very singular event. The reactor complex at Fukushima consists of 5 reactors, so it's a large complex, and these reactors were designed and built in the late 60s, early 1970s, and a very standard design of boiling water reactors. And the siting is also fairly common. The siting is adjacent to the Pacific Ocean because of the proximity of water as a cooling sink. As I think we've now recognized a few times in the course, a nuclear reactor complex involves an amazingly complex mechanical system. It also involves, by design, multiple layers of safety systems, and yet it also embodies the potential for catastrophic release of radioactive material into the atmosphere, into water, into land, leading to the possibility of immediate health hazards, including lethal health hazards for the surrounding population, but also the possibility of long-term contamination of both water and land. Land may be contaminated for centuries or even thousands of years and prevented from use for agricultural purposes or even living purposes. And water contamination also can be highly dangerous and harmful for human habitation. The Fukushima Daiishi plant and other nuclear plants in Japan were constructed under what just has to be described as being loose oversight of multiple atomic safety governmental organizations, which collectively have a poor record of effective oversight of the industry. The nuclear plant at Fukushima and many other plants in Japan are owned by TEPCO, Tokyo Energy Production Company, which is the largest energy company in the world, which also has a poor record of safety and procedural conformance. And there's lots of information in the book, which I've now decided not to ask you to read, but it is still available to you as a resource. So what happened in the disaster? I indicated at the start that in one sense this was a very rare set of circumstances. But on March 11th, 2011 in the afternoon, there was a major earthquake 80 miles offshore, which eventually turned out to be a 9.0 earthquake, one of the largest earthquakes that the planet has experienced in the past decade or so. And yet, it's also well known that Japan is in a high earthquake activity zone, and planning for earthquake and for seismic events was absolutely a part of the design of this set of reactors. An automatic shutdown process began within minutes of the earthquake sensors indicating a major earthquake had occurred. But within minutes, earthquake damage had led to damage to the electric power grid, and external power to the complex was lost within minutes. Emergency generators were started automatically to continue the coolant operations to the cores and to the essential functions of the plant. The real cause of disaster was the subsequent tsunami, which arrived at Japan's coast 41 minutes after the quake, and a gigantic surge of 45 feet, a 45-foot surge, overwhelmed the seawalls of the Fukushima Daiishi plant. It also killed within an hour, killed 19,000 people, either dead or missing. And there was a second surge as well, even higher. This graph is difficult for you to read during this video, but it's also available in the slides, and you can blow it up and look at it more closely. It is the events of the first hour. And I included here to indicate what a rush of catastrophic activity occurred within an hour, which it turned out was simply beyond the capacity of the safety systems, the operators, the supervisors, and the government to adequately control. So we don't need reminding, probably, that reactors are among the most complex industrial systems that exist on the planet. And accidents are common in tightly coupled industrial systems. This is what we've learned from Charles Perrow, but we've also seen from many other examples throughout the course. So the question arises, how can we have reasonable confidence in the safety of nuclear reactors? Perrow's answer to that question, as I think you now know, both from the book and from subsequent readings that you've done, is that we can't have reasonable confidence in nuclear reactors. They are too dangerous. There is slim likelihood of catastrophic accidents, and the earthquake and tsunami is his strongest example, and therefore we should dispense with nuclear energy until it is substantially safer in any case. But unfortunately, this is not an acceptable answer. The world already has hundreds of reactors. There are 98 reactors in the United States alone. And so we must do the very best job we can to enhance their design, to identify risks, to design management plans that minimize the risk of catastrophic accident. The worst kind of accident is a LOCA accident, a loss of coolant accident and subsequent core meltdown of the nuclear fuels, which can lead in the end to catastrophic release of substantial amounts of radiation. But a second level of risk, also catastrophic in potential, is the storage of spent fuel on premises in canisters, often in water-cooled tanks or ponds on the premise of the nuclear reactor complex. And we still have not solved the problem of storage of spent nuclear fuel. So let's think just a little bit about the reactor complex. There are 6 units. They were designed and implemented in the 1960s and 70s, provided by General Electric. They consist of uranium oxide fuel pellets enclosed in metal rods and then subject to nuclear fission processes in water-cooled cores. There's also a secondary containment structure, which is designed and implemented in order to contain the possibility of explosion or release of nuclear materials from the core. The secondary containment structure is designed to be able to contain those materials. Interestingly enough, this is one difference between modern reactors and the Chernobyl reactor. Another piece of scientific information that's really important to know about nuclear reactors is that once the nuclear fission process has ended by inserting graphite rods, reducing the flow of neutrons and therefore stopping the fission process, the danger is not over at that point because heat production from secondary nuclear decay continues at a very high level for an extended period of time, and therefore the core must be cooled for an extended period of time. It must be immersed in water, in the hot water reactors in any case, and this cooling process must continue for hours after the scram, the insertion of control rods to end the fission process. Furthermore, there are complex processes of instrumentation, measurement processes, and remote control of equipment, which are simply crucial for the safe continuing operations of the nuclear power plant. All of this is dependent on available electricity. Loss of coolant accidents are the most serious, and if the coolant system and circulating water fail, if power is lost to the pumps which circulate this extremely hot pressurized water, the temperature rises catastrophically, which leads to the melting of fuel rods, subsequent unintended but now predictable creation of hydrogen gas because of chemical reactions which occur, and therefore the likelihood of hydrogen explosions, the possibility of breach of containment, and the release of radioactive materials in large quantities. There are secondary lines of defense in this reactor and most reactors built since the 1970s, including especially something called an isolation condenser, which is designed to draw off excess steam to prevent a steam explosion, pressures rising to exceeding the capacity of the containment vessels. There are also secondary emergency generators to be called into play within seconds or even fractions of a second in the event of loss of external electric power. And something called the reaction core isolation cooling system, which is powered by steam, not electricity, and is supported by batteries for the control equipment. So there are multiple layers of defense which are intended to prevent the possibility of a loss of cooling accident. Nonetheless, within hours, to less than 3 hours, core melting had begun in Unit 1 reactor building by 6 p.m. And there was already the availability of high radiation levels in the structure. An emergency evacuation of 3 kilometers around the plant was ordered by the central government. And by the way, the central government's performance during this period was also somewhat chaotic. Communication processes within the government and between the government and TEPCO and between the government and the site were all haphazard and disrupted by the major disruption of cell towers and landline communications created by both the earthquake and the tsunami. There was a very clear set of issues about safety planning, which went into the design of these plants. And here I'd like to emphasize the idea of a design-based accident. Here I'm quoting from Lockbaum, and this is from the book that you haven't read, but you do have as a resource. I'll read the quotation because it's quite important for our purposes. Developers of nuclear power historically have regarded such severe events as those I've just described as so unlikely that they do not need to be factored into a nuclear plant's design. The experts could not imagine that such a cascading failure of safety systems would really occur. So the regulations required only that reactors be able to survive conditions occurring far less severe accidents known as design basis accidents. By contrast, a severe accident is designed as one which occurs outside the perimeter of a design base accident. And it is, of course, the tragic reality that the occurrences which developed at Fukushima Daiishi were severe accidents, not design base accidents. The Japanese government's regulation of nuclear power is faulted by Lockbaum and by many other observers of this accident. Here again, I'd like to read a quote from Lockbaum because I think it kind of gives you a sense of the complexity and inadequacy of the regulatory process in Japan. Quoting, "Responsibility was divided among multiple government agencies whose missions sometimes overlapped or conflicted. Japan's 54 commercial nuclear power plants were regulated by the Nuclear and Industry Safety Agency, NISA, which operated under the jurisdiction of the Ministry of Economy, Trade, and Industry, METI. NISA shared some responsibilities with the Ministry of Education, Culture, Sports, Science, and Technology, MEXT, which had a dual role to promote nuclear energy and to ensure its safe operation." I read this quote because it illustrates the critical flaw in regulation and promotion of nuclear energy which occurred in Japan, and which for a lot of our history was true also in the US system of regulation and promotion of nuclear energy. And that is the fact that there were multiple agencies with conflicting briefs, conflicting responsibilities, and also conflicting agendas. If an agency is both charged to promote nuclear energy and also to ensure safety, this is an obvious conflict of institutional interest. It is quite clear that nuclear energy is economically crucial for Japan, having no direct access to other sources of fuel. Petroleum is not available in Japan. Coal is available only in small quantities. And therefore, there is very high pressure to have alternative sources of energy. And consequently, there is also strong pressure from industry and from economic interests on the regulatory entities to be receptive to the development of nuclear power. Quoting Lockbaum again, Japan's nuclear quest entwined government and private industry in a tight alliance. The push by business leaders, politicians, academics, and bureaucrats, steamrolled the few experts who raised warnings. It was difficult, in other words, for Japan's decision-making process to take proper account of independent scientific and technical and even public opinion on the subject of the safety of nuclear power. So let's turn now to implications for the Nuclear Regulatory Commission in the United States. One reason why I think the Lockbaum book about Fukushima is so interesting is that it is interspersed with Lockbaum and his associates' own observations about the situation of the Nuclear Regulatory Commission as well. And I actually look at the Fukushima book as being the closest thing we currently have to a dispassionate assessment of the effectiveness of the Nuclear Regulatory Commission in the United States. It is clear, both from Fukushima, from Chernobyl, from 3 Mile Island, and from the regular patter of accidents which occur without catastrophic consequences in nuclear power plants, and we're going to talk about some of them in not too many weeks. It is very clear that the nuclear industry requires government oversight and regulation. The stakes are simply too high to leave management of nuclear power to private operators and owners whose interests are defined by the profitability of their companies, no matter what happy talk they may offer about putting the safety of the public first. That is not their leading business interest, and therefore government regulation is essential. The Nuclear Regulatory Commission exists to guarantee the safe design and opening and management of nuclear power plants. And some observers would say that it's done a good job. Only one really catastrophic accident has occurred. But that's not the view that Lockbaum takes, and it's not the view that Perot takes and other expert independent observers have taken. There are some specific reasons why the NRC is hampered in its ability to regulate the nuclear industry. One is the fact of industry capture. The industry which they are attempting to regulate is itself a very powerful economic force in the US economy and also a very powerful political force. They are therefore able to exert their influence through the Congress. And congressional pressure on the Nuclear Regulatory Commission has been really intense through much of its history. Reduction of inspections has been an explicit demand of relevant committees in both the House and the Senate. There has also been, by the Nuclear Regulatory Commission, a disregard of safety-oriented voices from the public. There are requirements of public disclosure, public comment, but NRC has not been even-handed in its listening processes. It has instead listened to experts, quote, experts within the industry. NRC possesses professional scientific staff. It possesses advisory committees of scientists, engineers, and experts, often from industry consulting firms, but advisory committees which advise it about nuclear safety, and most crucially, it is governed by 5 presidentially appointed commissioners. Here is a flow chart, an organization chart for the US Nuclear Regulatory Commission, and again, you can look at the slide a little bit more fully in the slides. But here's another interesting point. We would not want all of our kind of judgment about the safety of nuclear power to come from the industry. And we probably wouldn't want it to come from the Congress. We would like there to be independent scientific experts who have a certain amount of autonomy from the industry, autonomy from government, and an ability to arrive at their judgments and their scientific concerns reasonably independently, reasonably autonomously. In fact, assessment of nuclear safety is highly contested. And if you read about siting decisions, Seabrook, for example, in New Hampshire, the level of political contest over the siting of a plant or even the establishment of a new plant is highly contested. Industry groups and government agencies have a very strong interest in reassuring the public about the safety of nuclear power, which does not necessarily conduce to confidence in the neutrality and objectivity of the scientific judgment which they are bringing forward. So what about independent voices? Well, the Union of Concerned Scientists has shown an historical ability and interest in providing substantial effort at developing sustained scientific and engineering expertise on nuclear power. It has offered consistent, deep, and technically expert reports on nuclear power, atomic energy. David Lochbaum, the author of the book about Fukushima, is in fact a leading professional expert within the Union of Concerned Scientists. And it is interesting to me to find, in reading what he has to say in the Fukushima book, that he has a high opinion of the technical staff, the scientists, and the advisors who prepare recommendations for NRC consideration. But unfortunately, he has a low opinion of the willingness of the 5 commissioners to adopt costly recommendations that are strongly opposed by the nuclear industry. So the technical expertise of NRC is high, but the political independence and the ability to maintain priority on safety above economic concerns, that ability is not well established through the political structure of 5 presidentially appointed commissioners. And in fact, Lochbaum believes NRC has failed to learn the most important lessons from the Fukushima disaster. That's a very important finding on Lochbaum's part. He finds, this is again a quote that I'd like to read to you because I think it's a really important quote, the Japanese government simply seems in denial about the very real potential for another catastrophic accident. This is post-Fukushima. In the United States, the NRC has also continued operating in denial mode. It turned down a petition requesting that it expand emergency evacuation planning to 25 miles from nuclear reactors, despite the evidence at Fukushima that dangerous levels of radiation can extend at least that far if a meltdown occurs. And now, of course, we have on-the-ground empirical experience about this. I'm continuing the quote now, it decided to do nothing about the risk of fire at overstuffed, spent fuel ponds, and it rejected the main recommendation of its own near-term task force to revise its regulatory framework. The NRC and the industry instead are relying on the flawed FLEX program as a panacea for any and all safety vulnerabilities that go beyond design basis. These are really quite damning conclusions on the part of Lochbaum. He believes, in fact, that NRC is excessively susceptible to influence and pressure from the nuclear power industry and to the elected officials who favor economic growth over hypothetical safety concerns, with the result that NRC tends to err in favor of the economic interests of the industry. Quoting Lochbaum, like many regulatory agencies, the NRC occupies uneasy ground between the need to guard public safety and the pressure from the industry it regulates to get off its back. When push comes to shove in that balancing act, the nuclear industry knows it can count on a sympathetic hearing in Congress. With millions of customers, the nation's nuclear utilities are an influential lobbying group. And in particular, the NRC's commissioners were entirely reluctant to consider safety requirements exceeding, quote, design basis accidents. But we've already seen why that is a huge problem in planning for safety about nuclear power plants. NRC, after the Fukushima disaster, established a committee. The commissioners established a committee, a task force called the Near-Term Task Force Committee, consisting of independent experts, real experts on nuclear safety, to review the findings of, or the experience of the Fukushima disaster, and to incorporate lessons from Fukushima into next steps that NRC should take. The key recommendation from the NTTF was that the regulatory framework should be anchored in a more strenuous standard of accident prevention, which would require plant owners to address beyond design basis accidents. So a standard which goes beyond the design basis accident standard. The Fukushima earthquake, I'm continuing this description of what the recommendation was. The Fukushima earthquake and tsunami events were beyond design basis. Nonetheless, they did occur, and the NTTF recommended that safety planning should incorporate consideration of these unlikely but possible events. And, big surprise, the commissioners directed that this recommendation should be tabled as too speculative and too costly. NTTF Task Force also addressed the issue of delegated regulation, which is a term that we've encountered elsewhere. FAA is deeply committed to delegated regulation with respect to the manufacturing industry, to Boeing basically. Delegated regulation, which provides it delegates to the industry many of the issues of certification and risk assessment. NTTF recommended making less use of delegated regulation. And quoting from Lockbaum, the task force also wanted NRC to reduce its reliance on industry voluntary initiatives, which were largely outside of regulatory control, and instead develop its own strong program for dealing with the unexpected, including severe accidents. This recommendation was also rejected by the NRC. In fact, Lockbaum and other experts, independent experts on nuclear safety, recommend that NRC should make use of an existing and rigorous plan for reactor safety, incorporating the results of severe accident mitigation alternatives, abbreviated as SAMA. And this is an approach, an analysis scheme already performed, but largely disregarded. In other words, there are SAMA analyses for existing power plants, which have very different implications for accident remediation, but those recommendations have been disregarded. Lockbaum is not optimistic that the Nuclear Regulatory Commission will be willing to undertake these substantial changes, which would entail significant enhancement of safety and would make a Fukushima-scale disaster less likely. But writing on the subject of a post-Fukushima conference, which was sponsored by the NRC, Lockbaum writes, quoting, "But by now it was apparent that little sentiment existed within the NRC for major changes, including those urged by its own near-term task force to expand the realm of adequate protection." And to remind all of us, what are some of the obstacles? There are 4 or 5 obstacles to effective regulation, 4 or 5 reasons why NRC is structurally disadvantaged in its official charge of ensuring, first and foremost, the safety of the public. First is the fact of political power and influence of the nuclear industry. Second is the influence which owners of nuclear power plants have, their ability basically to engage in regulatory capture, their ability to advise the NRC about the content of regulation, and also about the systems of inspection and oversight that the agency adopts. There's a great deal of interaction between industry and NRC. A related factor, the influences and lobbying points that come from having to do with the needs of the economy and the influence which that has on legislators who then reinforce the industry message. There's a third fact which Perot emphasizes, that the NRC is primarily governed by the Congress. Legislators themselves are vulnerable to the pressures and, frankly, campaign funding of the industry, and the industry demands for low regulation business environment. And this makes it difficult for NRC to carry out its role as an independent guarantor of the health and safety of the public. There's a fourth interesting factor which interferes with the public's ability to influence and also interferes with the NRC's ability to take a balanced approach to risk. And this is the fact that there is kind of a pervasive complacency within the professional nuclear community about the inherent safety of nuclear power. This is a fact which Lockbaum mentions. Quote, "Although the accident involved a failure of technology, even more worrisome was the role of the worldwide nuclear establishment, the close-knit culture that has championed nuclear energy politically economically and socially, while refusing to acknowledge and reduce the risks that accompany its operation. Time and time again, warning signs were ignored, near misses with calamity were written off. And this is nuclear experts, nuclear engineers, professors of nuclear engineering. I would describe this as an ideational factor that describes a mental framework for thinking about the technology and the public. And I believe that it is a very real factor in decision making, both within the industry and also in the regulatory world. The complacency about nuclear safety described here makes safety regulation more difficult to achieve, but paradoxically, it makes the safe use of nuclear power more unlikely. Only when the risks are confronted with complete transparency and honesty will it be possible to design regulatory systems that do an adequate job of ensuring the safety and health of the public. Lockbaum is quoted by Perot in one of his articles that you've read. This is a Lockbaum quote. "The NRC is as good a regulator as Congress permits it to be. Right now, Congress doesn't want a good regulator." And to illustrate that fact, here are some comments from Senator Barbara Boxer at a Senate hearing on the Nuclear Regulatory Commission following reports about the Fukushima disaster. This is now quoting Senator Boxer from her official statement. Although Chairman McFarlane of NRC said, when she announced her resignation, she had assured that, quote, the agency implemented lessons learned from the tragic accident at Fukushima. She said the American people can be confident that such an accident will never take place here. Continuing Barbara Boxer, I say the reality is not a single one of those 12 key safety recommendations made by the Fukushima Near-Term Task Force has been implemented. Some reactor operators are still not in compliance with the safety requirements that were in place before the Fukushima disaster. The NRC has only completed its own action on 4 of 12 task force recommendations. It's a pretty damning statement from a state senator and member of the Oversight Committee. I've pulled together 4 sources of information about nuclear safety and about Fukushima in particular, and you may find these useful, not only to understand nuclear safety, but also these reports may be useful for you in the construction of your the case studies which you're working on right now. National Research Council is probably the most comprehensive and most independent. The International Atomic Energy Agency did a major report. I would also describe that as being reasonably independent. The World Nuclear Association, which is an industry group, I've posted that report on the website, on Canvas, and I think if you read it, you'll find that it has a worrisome underlying tone of calm about the accident, which makes one think, well, kind of routine, and we got through it, and things are okay. And then I also have refer you to the Senate Committee on Environment and Public Works, from which I quoted the Barbara Boxer observations. So, thank you.